Hi guys, what we're going to do today is we're going to look at a very important thing in complex numbers. So it's part 3 folder on your Teams file, and basically it's kind of always the second question that comes up in an exam on complex numbers. So with complex numbers we always deal with this idea that z is equal to something. Now I know I do my z, it's a bit funny with the little line across there, but you're going to see a lot of this. So you'll have z is equal to 1 plus 2i here, and z2 is equal to 5 minus 2i here. So you're going to have to get used to that. And what we're going to be asked to do is we're going to be asked to manipulate these somehow. So we're going to be asked to either add them, subtract them, multiply or divide them. And today we're going to look at a bit of multiplying. Now this is the slightly easier version of multiplying. There is a bit of a harder version that we'll do in the next couple of days. So, typical question that comes up in an exam is find 3z or find z1 plus z2, and it's just exactly as it looks. What you do is you take z1, you take z2, and you do what's asked of you here. So for the first one it says 3 times z1. So I'm going to write 3 here, and very importantly and we had this yesterday, I'm going to put them in brackets. I'm going to go, because it's z1, I'm going to replace that with 1 plus 2i. So what I have is 3 times 1 plus 2i. And then I'm just going to multiply it out, just like you do in algebra. So 3 times 1 gives me 3, and 3 times 2i gives me 6i. And that's my answer there. Now, this is in the form a plus b times I. And you'll see that a lot. Answer in that form, a being your real number here, so a being 3, and I being my imaginary number or a complex number, and that is 6i. So real part, imaginary part. And that's important for the graphs we're going to do, and we'll probably start graphs tomorrow. So second one says z1 plus z2. Again, very, very easy, but I'm going to put it in brackets just to be sure. So z1 is 1 plus 2i plus z2, which is 5 minus 2i. And then, like yesterday, I can get rid of my brackets. So there's nothing multiplying this, so this is just going to be 1 plus 2i. This is a plus and this is a positive, so it's going to be plus 5. This is a plus and this is a negative, so it's going to be minus 2i. Just be careful there. Remember our sign rules. A plus and a minus gives me a minus. And here we have the real parts, 1 and 5, so that's 1 plus 5 gives me 6. And the negative, or not the negative parts, the complex number parts, 2i minus 2i cancel, so I can put 6 plus 0i, or I can just put 6. It's up to you. So that has no imaginary part, and that's okay. Second one here, or third one here, 2 times z1 minus z2. So what I'm doing is I'm taking what I've done here and what I've done here, and I'm adding them together in this new question. So I'm going to start off with multiplying, figuring out what 2 times z1 is. So I'm going to go 2, bracket, z1 is 1 plus 2i. And then it's minus z2, and I'm going to put it in brackets. So 5 minus 2i. Again, I'm just going to multiply this out. 2 times 1 gives me 2, and 2 times 2i gives me 4i. Minus 5 here, that gives me minus 5. And a minus here gives me a plus, so that's very important. So it's plus 2i. Again, we're looking to add together our complex number bits and our real number bits. So 2 minus 5 gives me minus 3. So that minus 3 is important, particularly when it comes to graphing it. And plus 4i plus 2i gives me plus 6i. Again, it doesn't matter if I put 6i minus 3, so the order doesn't make a difference. And finally, z1 minus 3 times z2. So z1 in this case is 1 plus 2i. Again, I put it in brackets just to be sure. Minus 3 times z2, and z2 is 5 minus 2i there. So this bracket has nothing multiplied, so it just stays as 1 plus 2i. Minus 3 by 5 gives me minus 15. And minus 3 by minus 2 gives me plus 6i. So remember, minus 15 and minus gives me plus 6i. Then I have 1 minus 15, gives me minus 14. And I have 2i plus 6i gives me 8i. And that's how we start multiplying out complex numbers.